So, okay, so I see what you're saying. So, like, a phospholipid can, like, move from here to here, and maybe this guy can move over there, and they can probably, like, rotate around, I imagine. So they can kind of, like,
Yeah, exactly.
spin a bit or
They can
stuff.
spin, they can switch their positions relative to each other. Exactly.
Cool. Okay, Sarah, so I dig all of that. So we have these phospholipids that form bilayers when they're exposed to water on both sides, both outside the cell and inside the cell. And the bilayers hide the hydrophobic tails, like in the middle of this hydrophobic core where there's no water. But how do we know that they're fluid? I mean, how do we know that, like, that one phospholipid can kind of change places within one leaflet and not involving phospholipids moving between the two leaflets, though?
Fair enough, Marty. Fair enough. I like that. A good scientist always asks how we can determine things experimentally. So there is actually a specific way that scientists figured out the fluidity of the phospholipid bilayer, and that is through an experiment called FRAP.
Like the milkshake.
Not exactly. So the F in FRAP stands for fluorescence.
Oh, very much unlike a milkshake.
Not quite like a milkshake. And so what fluorescence means is that scientists they took one sort of like layer of the bilayer and they added fluorescent tags to it. So bring this in here. So what they did is they went in and they tagged each phospholipid individually with a fluorescent marker so that if you looked under a microscope, you could actually see the membrane glowing.
Okay, and so like these little hats are like the fluorescent markers for each one of these phospholipids.
Yeah, they're sort of fluorescent tags, exactly.
Okay, and the one that, does it matter that some of them are kind of pointing in one direction and some of them are pointing in another direction?
Not exactly. I wouldn't worry too much about that. These are all tagged, and remember, you know, we know now that the bilayer is fluid, so these head groups can rotate around. And
yeah, I see.
Yeah, so they're all basically fluorescently tagged. And so what happens in the experiment next is a process called photobleaching. And so what this entails is that you can shine a really intense laser on one particular part of the membrane.
Okay.
So you can pick, one specific region, you can shine a really intense laser, and it will cause the tags to fall off. So we're shining our laser, and the tags are coming off, and now what we have is this dark spot. So we have everything's glowing, but then we have a dark spot kind of in the middle. And now what we're looking at is, all right, so are these phospholipids moving around? Is there fluidity here? And I guess what would you expect to happen if the phospholipids can't move, they're fixed in place, maybe they can rotate a little bit, but there's no real fluidity.
Okay, so if there's no membrane fluidity, which is to say that the phospholipids can't kind of move back and forth, then I imagine that this region is going to be dark no matter how long we wait, while the rest of the membrane is going to be fluorescent.
Yeah, exactly. So what you'd see, you could wait for a while, you could look again under a microscope, and you'd just see maybe some amount of fluorescence and then a dark spot. And no matter how long you wait, the dark spot's just kind of sitting there. But what would happen if, in fact, the phospholipids can move and rearrange relative to each other?
Okay, so then we just play the game that we've been playing already. So we move some phospholipids around from one side to the other, and they can all move in the same leaflet, and eventually, I guess I can kind of see that eventually some of the phospholipids end up, the fluorescent phospholipids kind of end up in the spot that we had previously bleached.
Yeah, that's exactly, and in fact, this is what they observed. So they initially fluorescently tagged everything. They then made one dark spot, but after they waited for a while, there was this recovery. So the dark spot went away, and so that's the R and the A. So we have this fluorescent recovery after photobleaching. And because the dark spot went away, it meant that the tagged phospholipids, the phospholipids that still had their tags on, were kind of moving around, filling in the dark spot, and scientists concluded that, in fact, the membrane is fluid.
Awesome. Well, I'm really glad I bumped into you, Sarah. Thanks for explaining all that to me.
Yeah,
That was easy.
it was a pleasure. Anytime.